Morning, guys. Miss Meadows here, just gonna go over your notes for today. I'm gonna do this front page with you, and then you're gonna work on the back page with your shoulder buddy, check answers with your substitute, and then do some classwork today. So it should be a pretty easy day. Sorry I'm not there with you, but we're actually kind of starting a new unit. We're gonna review adding, subtracting, and multiplying polynomials. So far we've been mainly focused on just x to the first power or y to the first power, which is mainly dealing with linear type relationships. We're now going to move into quadratics and higher level terms like that, and that's what a polynomial is going to be doing. It's going to be expressing things you can see to the fourth, to the second, to the third, all over the place here. All we want to practice is how to add and subtract them. I think this is stuff you've done in Algebra 1 and Algebra 2, so hopefully it'll go well. Let's start with an adding example here. Adding is just combining like terms. So we need to know what a term is and what like terms are. Terms are each of these things that are separated by the pluses and minuses as you go along. So we've got 2y to the fourth, negative 3y squared, positive y. We've got terms over here. Like terms means that their numbers can be different, their signs can be different, but their variable and exponents have to be exactly the same. So in this expression, my first like terms that I can put together are 2y to the fourth and 4y to the fourth, which gives me 6y to the fourth. You're just adding the coefficients on the front and then just tagging it on the y to the fourth. Don't try to add exponents. So there's 2 and 4y, which is a total of 6y to the fourths. The next one we can do are the negative 3y squared and the positive 7y squared. It's together for a total of positive 4y squareds. And then lastly, we've got a y and a 6y. That's a total of 7. That's it. There's nothing more you can do with that because each of those are different terms because they have different exponents. All right, let's try B. B is a subtracting example, and we need to be real careful with the subtraction and make sure that before we combine like terms, we distribute the negative 1. What you're really going to do is change it from subtracting the second all of these to adding, and then change the sign of all of the rest of them. So into an addition problem by making it a plus. But that means each one of these has to become the opposite. So now we're going to have negative m to the third, we're going to have negative 7m squared, and we're going to have positive 3. Now we can just go ahead and combine like terms. We have a negative 3m and a negative 3m to the third and a negative m to the third. That's 4m's to the third. We have a negative 8m squared and a negative 7m squared. That's negative 15m squared. And then finally 4 and 3 is 7. Not too bad, but that distributing the negative, you've got to be careful with that. Alright, this one is going to involve distributing the distributive property and combining like terms. So on the front here, before I can start combining like terms, I want to distribute this 4, all of the terms on the inside. So that's just multiplying everything by 4, 4a squared minus x squared, minus 12x plus 28. And now real careful with this, we're distributing a negative 5. So negative 5 times each one of these. So the first one is negative 10x squared, but the next one is a negative 5 times negative 8, which is positive 40x. And then finally negative 5 times negative 4, positive 20. Okay, so like terms, we've got 4x squared and negative 10x is a negative 6x squared, negative 12x and positive 40x. Oh, notice this is a non-calculator skill that we're doing here, so we gotta do this in our head. It's 28x, and then lastly 28 and positive 20, so that's positive 48. So that is our final answer. Alright, so that's adding and subtracting polynomials. I'm going to give you practice with that on the back, but let me go ahead and finish this paper so we can be done with listening to Miss Meadows on a video. So let's try multiplying. You guys are really good at this. I asked you about this last class and you said that you're foiling. So we'll just do this one together. Be real careful because you are now multiplying variables, and now we do need to think about those exponents adding up. But let's go ahead and try this out. You're going to multiply the 6m times 4m, and then you're going to multiply 6m times negative 3. So the numbers on the front, 6 and 4, are going to multiply to 24. M times m is, you add the exponents, 1 and 1 is m squared. Next we've got 6m times negative 3. That's a negative 18m. Then you're going to repeat this with 1. So now you're going to distribute a 1 times 4m and a 1 times negative 3. So that just becomes 4m minus 3. Once you do that, sometimes you also have to go back up and do some combining like terms. And oftentimes, not always, but oftentimes the middle two terms will add together because they will be like terms. So nothing goes with the 24m squared. But negative 18m and positive 4m is a negative 14m, and then that negative on the outside. So our final simplified polygon is that. Okay, so the next one, we're going to do exactly the same way, but if you're careful, you might actually notice that in B, we have the same expression twice, just it's a plus and a minus. So I'm going to show you what happens. But you might have already seen this before. Something special happens in the middle. So I'm going to do 3p times 3p and 3p times negative 12. Multiply numbers and get 9. The exponents are 1 and 1, so you add them and you get p to the second. 3p times negative 11 is negative 33p. And then we'll repeat with the 11. 11 times 3p is positive 33p. 11 times negative 11 is negative 21. So what ends up happening is, just like the last one, we can combine like terms in the middle here, but don't combine. And we end up with 9p squared. These actually end up canceling out. Sometimes the middles cancel out, and you're only left with negative 121. So why did that happen? It happened because, example, exact same terms, just that they were added in the first one and subtracted in the second one. If you recall from Algebra 1, I think, they call this the difference of squares. So when you go backwards, you know how to factor that. Well, now we want to be able to move forwards and make that a little quicker. So if you see exactly the same terms, just a plus and a minus in the middle, you could actually kind of skip the steps by just squaring 3p, 9p squared, and squaring 11, 121, and then just make it a difference of squares in the middle. Let's try that with C. With C, we have an r squared that we're going to have to deal with later after we do our distributing, excuse me. But notice we have the same thing we had last time. We have the same terms, 4r and 1, but just a plus and a minus. So to speed it up a little bit, you can just say, I can just make this a difference of squares. Do 4r times 4r, which is 16r squared, and then do 1, which is negative 1. And know that the middle terms that I'm skipping cancel out because of the difference of squares thing that we just did in part B. If you'd rather write it all out and still double distributive, you should end up with the same answer. Now we need to parentheses back in here because we have another thing to distribute, which is the r squared right there. So we distribute r squared to the 16r squared and r squared to the 1. Alright, 16r squared is just 16, and then you add your exponents. So it's r to the 4th. And then r squared times negative 1 is negative r squared. Alright, last one, another interesting one. I even put a little star next to it because this is probably the one that students make the most mistakes on when it comes to polynomials. You need to be careful when this square is on the inside. A lot of students think, oh, you just square each one and you're done. But that's not actually what we're saying. We're saying that the entire parentheses is being multiplied by itself. That's what squaring means. So 2m plus 5 parentheses squared means 2m plus 5 times 2m plus 5. So it's just long and tedious as the last two, or last three. And I have to distribute and distribute. Now this one is not the difference of squares because it doesn't have a plus and a minus. It has two pluses. So we're going to have to go through the whole FOILing process. 2m times 2m is 4m squared. 2m times 5 is 10m. And repeated on the bottom, 5 times 2 is 10m. And 5 times 5 is 25. Notice our middle term cancel out because we didn't have a plus and a minus. So we do end up with a middle term of 20m. And we just tag on the 4m squared and the 25 at the end. Oh, sorry. So that ends up being our final answer. I'm almost done talking at you, and then you can get some practice. I want you to be able to do one of these word problems, and it's a bit tricky. You're actually going to see something like this on your quarterly, so we really want to be aware of how you're supposed to set this up and what they're asking you to do. So let's read. It says the diagram to the right represents a swimming pool that measures 8 feet by 20 feet and is surrounded that is the same width all the way around. So we can see the pool inside here. Here's your waves and your pool, and then your deck is going around the outside. It says what is the area of the swimming pool? So it's just a rectangle, so area equals length times width. Remember, this is non-calculator, so we got to do 20 times 8 in our head. Get 160 square feet. Then it says, do we know the width of the pool, of the deck, excuse me. The width of the deck, well, that's this thing on the outside. It didn't tell us. It just says X. So we're going to say nope. So now they've asked you to try to write an expression that models the area of the pool and the deck together. Simplify it so it's in standard form. Ugh. Well, it is going to be length times width again, but now we need the whole length from here to here, and we need the whole width from top to bottom. How are we going to figure that out? Well, what we can see is that on each side of the 20 feet swimming pool length, we have an X on the left and an X on the right. All that, X plus 20 plus X, or 2X plus 20. You guys kind of see that? And then for the width, we know it's 8 feet, but then there's an added X on the bottom and an added X on the top for the deck. So that's X plus 8 plus another X, or 2X plus 8. So now, when I go to find my, or to represent my area, I want to multiply this length expression by this width expression. Again, it's still length times width, but it's 2X plus 20 times 2X plus 8. Since I don't know what X is, I'm just going to have to write it like that. Alright, we're back to doing our double distributive, or FOILing. 2X times 2X is 4X squared. 2X times 8 is 16X. 20 times 2X is 40X. And 20 times 8 is 160. And then we are almost done. Standard form is just no parentheses, so we just combine like terms. 4X squared plus 56X plus 160 is how you would represent the area of the deck and the pool all together. Alright, last question. If we end up knowing that the width of the deck is 3 feet, what is the total area of the pool and deck? Now, they've told us what X equals. They're straight up just saying X equals 3. Why couldn't they do there? Now what I need to do is I need to figure out how wide long it is. So I can actually just plug X into this expression right here, and I get, let me write it below since I'm out of room. My length is equal to 2 times 3 plus 20, which is 26. And my width is equal to 2 times 3 plus 8. That's 14. So now that we know it, we've got 26 feet by 14 feet. So that's our last step. To find the area, we're still going to do length times width. 26 times 14. Oh no, I don't know what that is. Let's do some long math, or multiplication. 24, 4, 0, 6, and 2. what is that, 364, guys? Did I get that right? I hope so. So that means the area of the pool and the deck all together is 364 square feet. And that's the end of that. That's a lot of decking, because it went up 160 to 364. All right, we're now going to try the back, and your substitute has the answers to go over after everybody has gotten that done, and then you're going to do a classwork activity. We'll see you Friday. Have a great day, guys.